Hi, everyone. Thank you for joining DataCon LA 2021. Welcome to the BI Reporting Business Use Cases track. My name is Hannah, your host, and our co-host today is Hestia. We will be moderating the chat and Q&A for you during the session. Today we have our guest, Brandon, and he will be talking about demystifying the art of business intelligence and data analytics. Without further ado, I'll hand this over to the speaker. Thanks for being here, Brandon.
Thank you, guys. Thanks, everyone. Welcome to DataCon LA. And my name is Brandon. I'm a software engineer. And this kind of talk and discussion is going to be just a kind of a more fundamentals, foundations, less technical, less coding, but more of let's start our foot off on understanding what is business intelligence, what is data analytics, and why are they such important and growing fields in today's technical arena. Okay, so a little bit about myself. Let me go ahead and there we go. So I'm a software engineer at AMPES, which is the Academy of Motion Picture Arts and Sciences, and you might know us as the industry or organization that hosts the Oscars every year. And one of the biggest questions I get all the time is, why do you need software engineers year round? And to answer that, and what I do on a daily basis is I help maintain and code the Academy members' streaming platforms. So we have kind of a mini Netflix for all of our members. And then we have mobile apps. And we have things like nickel screenwriting competitions and other various things that happen year round. We have our Academy Museum opening up very soon in Hollywood. So there's a lot more than meets the eye when it comes to the Academy. So that's what I do. And please, if you have any questions at the end, personal or tech related, feel free to ask me and we can go over them. So this is going to be full of like memes and sort of funny images, but this is kind of my favorite one that describes what I do on a day-to-day basis, besides actually working with the Oscars. It's kind of yelling at the computer and being frustrated, but yeah, this is, and what people think that I do as well. And then I wanted to address the elephant in the room before any of you guys get started on your coding journey or your data analytics journey. You have to love the process. It's, if you guys are students, if you guys are in the industry, either way, you're going to understand that it's a love-hate relationship. So it's going to be a little bit stressful and a little bit time-consuming and maybe frustrating at times, but it is all love, and we're all just trying to solve problems here. And that's what I love most about the industry and being in tech in general. So a little bit about my tech stack, or this is one of the many stacks that I work with particularly. And this is we have a SQL backend, so it's Microsoft Dynamics. We're a Microsoft shop. I interface with the SQL Management Studio, and I build the reports in Power BI Desktop and Report Builder. Again, there are many different stacks that can be used. And what I mean by that is you can have a SQL stack, you can have one that's more like NoSQL, JSON, you can be making API calls. As a data analyst, you're kind of forced to work with any type of data set. Whatever your data set your company ends up using, then that is what you have to be working with and be comfortable with too. But this is the one that I started with, and this is probably very familiar with you guys as well. And a little bit of what we're going to be going over today. So the introduction, which we went over. So what I kind of do, I'm going to try and go over the history of big data, data science, and analytics. So where did it all come from? Where did it all stem from, really? Data scientists versus data analysts, getting those two job titles and finding out their differences, how they're similar. The 4 parts of the reporting lifecycle. I think this is going to be important for the foundations as well. Tips and tricks, and then we'll have a couple of minutes for Q&A at the end. So a brief history of big data. where did it all start, right? So in 1999, I'm not too sure if you are old enough to know or remember these sites. So there was, static HTML pages, serving data and content to users, and the primary role was to provide value and give a place for people to um, click and see get some sort of interaction or response. Obviously, styling and cosmetics, CSS wasn't too big in this era, but it was mainly for, hey, let's get something up there and let's start, you know, giving some value to these users. And these are two huge websites now that they're multi-billion-dollar industries. So the emergence of the internet, you have Web 2.0, which you just saw those websites, and then you have relational databases, Moore's law. So the idea that um, every year the ability to store data becomes exponentially faster. So you remember those small flash drives that we used to have back in the day that we used to store like maybe 512 megabytes. Now they store probably about 2 terabytes worth of data. So with the expansion of being able to store more data in a smaller space, and also the birth of more computing power. So you have your graphics cards and things like that. You have the birth of the cloud. So I'm sure all of you have used a cloud platform before. If not, there's three big ones. There's AWS, which is Amazon's, Azure by Microsoft, and then Google Cloud Platform. And then that leads to the birth of machine learning and AI. So, and then the birth of social media as well. So advertising, and now you have social media and you have things like that starting to collect data from users. So you see people walking around with their cell phones and things like that. And now, if you can imagine the way money flows in our market, money is basically everywhere, and so is data. So I think the best picture to show that is this one here, where everyone's kind of looking like a 0 and 1 matrix looking thing, because we are the pools of data for these businesses to figure out and kind of understand where we're going to be going next. So this led to the birth of the word data mining. And I think this is an important definition to talk about. It's the practice of analyzing large databases in order to generate new information, right? What's the point of having data without being able to find out more about it? I know this is a wheat to flour sort of picture, but I think this is the best analogy for how the wheat starts as kind of grains and then gets refined, and then soon you'll see it on the shelf. But before that, it has to be cleaned, prepped, and all that. And same thing with data. Data can come in all shapes and sizes: unstructured, structured, semi-structured, and at the end of the day, it needs to be in a certain way for the data analyst to be able to consume it. So what are the types of big data that we work with? So there's structured data, as I referred to, and those are your SQL databases. Those are your Excel files, your TXT files. And these aren't just hundreds or thousands of rows. These are millions of rows of data. So as you can imagine, the programming has allowed us to be able to kind of work on these millions of rows once at a time and alleviating a lot of the complexity and time consuming manner. So running sort of a command to like capitalize everything or kind of clean all that data within a single second makes it all easier. Unstructured data, these are things like reactions, event logging from different areas. So social media, when you like a post on Facebook or Instagram, all that stuff, these are like unstructured because they're not really categorized. They kind of just, we log them, but they don't really have a certain compliance or standard. Semi-structured data would be kind of like a credit card processor, as you see in the image, where you have this, card reader, but you have different companies that are in that card reader. So you have MasterCard, Visa card, and I'm sure you've probably had this experience before, but exporting your data, your payment transactions from MasterCard and Visa and Citibank or American Express, and they're all just in different formats, right? Even though they're all under the same category, which is they all have a balance, they all have a transaction ID and a name, but they all have different ways of standardizing the way they talk about them. So like grocery or gas, things like that. So those are the types of big data that we'll see very often and that we'll be making reports and visualizations out of. So in a nutshell, the birth of data mining plus computer science is this data science, essentially. Data science plus the birth of recurrent neural networks, you get machine learning. And then analogies plus memes is optimized learning, in my opinion. So data scientist versus data analyst, right? These are two job titles that you see nowadays. And what is the main difference? They're very similar in some ways, but also very different. Data scientists design and construct new processes for data modeling and production using prototypes, algorithms, predictive models, and custom analysis. Sounds like a lot of math, and it is. A lot of data scientists usually have PhDs in math or some other like algorithmic field, computer science, physics, and this is more of a back-end sort of role where data scientists are in charge of the collection of the data as well as gathering predictive insights, forecasting, things like that. And usually larger companies will want to have data scientists because they have so much data that a data analyst wouldn't be able to do it on their own, essentially. I mean, if you're a small company, then yes, a data analyst would essentially be doing everything. There was a joke that I had that there's a company, there's another company's asking for someone to analyze their data. And they're like, do we hire a data scientist or data analyst? And the guy said, which one's the cheaper one? And the data analyst is, unfortunately, the job role that has a lower average salary, but in a small company, data analysts kind of control all the processes together. And so that leads us to data analysts. They examine large data sets. They do a lot of data mining, identify trends, develop charts, and create visual presentations to help businesses make more strategic decisions. So as you can see, there's a beautiful dashboard in front of us. And you as a data analyst will be building tools to help the business interface and make decisions on their own. So help them visualize and help them manipulate and massage data with parameters, with interaction that they need in the most concise and effective manner, essentially. So as you can imagine, this is a very important role as well. You must understand the big picture, like who is my client or who is my consumer of this report or this visualization? Is it the marketing team? Is it going to be the accounting team department? Is it my users? They want to see some analytics. So understanding who you're going to be building this for is one of the main things in the meat of data analytics and business intelligence too. So the analogy that I have, I don't know if everybody has seen the TV show Chopped, but it's a TV show on the Food Network. And it's where chefs compete for $25,000 or so, and they're creating this dish, and some judges on a panel judge their dish. So in this analogy, and I think this is probably the best way to kind of understand it, is Gordon Ramsay is your data analyst. The ingredients that he has, they're either gluten-free, organic. He takes them and he makes this wonderful dish. And of course, he's taking into account, who is this for? What is the theme of the event? Is it an Italian cuisine? Will it be a Chinese cuisine? And then also, what tools do I have to my disposal? So do I have a blender? Do I have a toaster? Do I have the oven? So in the technical terms, it would be, um, is this an internal report? Okay. And then if it is, then I can use internal tools. I don't need to have security. I don't need to open this up to the public or an IP. Who are my judges, or what theme is it? Is it who my manager? Is it, these kind of things, and you're presenting all this information in a nice, beautiful manner. And the data scientist would be the agricultural engineer, so the farmer, so to speak, and he or she is responsible for sort of generating like crop rotation, making sure that all the ingredients are cleaned and prepped properly. So this was a very interesting diagram that I came across while creating this presentation. And this is the data science hierarchy of needs. Normally, data analysts will live here in a large company. So in that boxed area that I have, you're going to be working with marketing. You're going to be interfacing with the business side on A/B testing, getting sentiment analysis, and seeing, hey, do our customers or consumers prefer this interface, or do they prefer this one? So you'll be getting an idea of which one do people enjoy more. You'll be doing a lot of aggregation, metrics, and analytics on training data and things like that. Of course, like I said before, in a large company, data analysts normally control the entire workflow of collecting data. But hopefully, you won't have to go through the entire data flow and ETL structure and all that stuff. So the main 4 parts of the reporting lifecycle, these are things that I think are very important. And when I start a report, what I think about every time before I start. And well, first, the types of data that can come in that I've worked with. I've worked with XML, and I'm sure you've seen XML. It's an older markup language that gets exported by SQL databases. There's JSON, which is the newer one, JavaScript or object notation. And this is more popular for web-based calls. So like if you do a call to an API, you'll see something similar to this. And then you have CSVs and SQL tables. So CSVs are obviously in Excel files, SQL tables, in databases and things like that. But your first thing is going to be looking for your data source. So the questions are going to be, where are we getting our data from? Do we have access to this data? And how many sources do we need to create the report that we're trying to accomplish here? And in an ideal situation, you'd only have one data source, but always be prepared to pull data from multiple sources. So you have an API call somewhere to a public resource. You have then a connection string to a SQL database, and then exporting from Tableau or Salesforce. And getting all this data together into one location that's the challenge, of course. And then you understand, once you have your sources, then you'll need to know what data sets do I need. So do I need the employee table from here? Do I need the users table or the payment table? Which fields do I need from the payment table? Do I need just the balance? Do I need the user IDs? Do I need these flags, things like that? And you want to bring them in, join them together, and then kind of massage the data a bit, bring them into one consolidated view. And then once you have a good idea of how many data sets you'll be needing, then you can understand how this will help achieve our end product. So in my experience, more is better. In my when I've built my reports, I've always had the business come back and say, hey, we need this field. And if I had not imported it before, I would have to go to the back end and re-add it to the API or re-add it to the store procedure and things like that. And I think if there's a slight hunch that you might need that field, I would say add it. Because just in case they need it, you'll have it ready for them on the front end in that user field. Okay. So the next thing would be preparations. So who is the data for, right? this is understanding the judges now, the judges side of things, your boss or who's going to be consuming the report, understanding which tools I'll be using. Am I going to be using Tableau? Am I going to be using Eclipse, some Git, uh, some Spark or SQL? And a lot of this stuff is very important to know because more often than not, you'll be using multiple tools to aggregate data. And you want to have those processes mapped out in your head before you start because you want to create the most elegant solution for your consumer, whoever that is, internal or external. And this is the part where you're going to start of if you're not given a wireframe already on how the report is going to look, this is where you're going to sort of Google best practices. You're going to say, oh, well, I've seen reports done like this from other companies. Let's kind of mimic that same process. And then if you have to tweak that report later to industry specific to your industry, then obviously that can be done. But first, start with a template that would work well that works well generally. So this is an example of a nice little visualization, and customizations is the fourth one here. Asking yourself, do they have permissions? Well, how will they be interfacing with it? So this is a endangered species list, and you have heat maps and legends showing like the different colors and things like that. So, I mean, obviously, I'm not too sure which industry would need this. Maybe National Geographic, they can stick this into their like pamphlet or magazine, but it's a very clear representation of when, like, just by looking at it, you can already tell what it's trying to tell you, essentially. So essentially, you have before you have a data set, and then after you have the beetles. But you have, so this one is particularly good because it tells you the writing percentage by alpha. So you can see very clearly that throughout the years that the writing responsibility was spread out throughout all the members of the members in the Beatles, except for Ringo, unfortunately. Writing percentage of artists over time, and then so this is actually interactive, but this is a screenshot. So, but having interactive is also very nice as well. So creating visualizations that are very easy to pinpoint what you're trying to gear your audience toward is what you're trying to get to. That's the goal. So tips, tricks, and stories. Things I wanted to talk about before I end you guys off. So an experienced chef is comfortable in the kitchen because he understands the fundamentals and foundations. So you should be able to understand your aggregate functions. So sum, count, group, order by, etc. There's way more. In SQL, we have partitions. We have things like cross and joins. Those things are very important as data analysts. Object-oriented programming, a little bit of understanding how data members work, the dot operator, accessing data members, functions, that sort of logic, PEMDAS, so to speak, order of operation, and then your relationships. So many to many, one to many, being able to look at an entity relationship diagram, things like that are going to set you up for success because every tool, as I've noticed, no matter what it is, the one that if they use data, they're going to use some form of these fundamentals. So data members, they're going to use some, like everything is going to have a sum field in Excel or SQL. Averaging, they're going to have standard deviation and things like that, no matter where you go in your journey. So a couple of stories that I have. I used to work for a company called BQE, and we created a SaaS billing, accounting, project management software for professional services. So if you hear me talking about a payment table or a transactions table or an employee table, then that's PTSD from when I was working there. But I think it gave me the best idea of what exactly do businesses want, right? And the key takeaway of working at that company was no matter how big or small your business is I noticed that you need something or someone to tell you what to do next, and whether that is to develop insights for you or whether that's a tool, and um, internally or externally. So more so, this was an internal tool, but externally it served its purpose as well. So internally, how are we going to save money? Are we utilizing our employees well enough? Are our projects uh, why are our projects 80% not like to completion? And how can we keep that standard going up? So this is an idea of how can we find out what our users want without them telling us. So kind of being a little bit of a Sherlock Holmes, saying, well, we have the data sets here, and it shows that we have a decline in sales on the red Tesla. So maybe we should think about changing that for a different color, or what is the reason for that exactly? Building visualizations is an 80-20 rule. So like cooking, the preparation process is about 80%. The actual cooking part is actually 20%. So the I would say before you start building your report, if you're tasked with it, to think about how should I, what tools will I be using, which data sets, all that stuff is going to be mapped out, write it down, and then it'll make the actual execution part much more simple and easy. And I think this principle has to go for all coding. I don't think that as a software engineer, I don't think that I've ever started coding immediately. I've always thought about which areas of this code do I need, which pages am I going to be using, um, which files, how many images, where is it stored, blah blah blah. So I think the same rule goes with data analytics: preparation first, and then you can put pen to paper as the last 20%. Couple key takeaways here. As a data analyst, you are responsible for bridging the gap for understanding between the data and assisting the business in making the right decisions. So I think we covered data analysts pretty well. And then business intelligence, when you're building industry-specific tools that allow the business to make sense of their own data and formulate decisions. So business intelligence is a tool, and a data analyst is a human, but also a tool. But yes, those are the two differences. Business intelligence, data analyst. So here are a couple of helpful resources I want to leave you guys with. I love this guy. He's a very underrated YouTuber, Shashank, on YouTube, and he does day in the life of a data scientist sort of videos. And if he's watching right now, shout out your channel. But he is instead of the day in the life coding where you see like I drink coffee, I wake up and then I code and then I take a nap. This is actually he's actually showing you the step-by-step working with a client, and he's showing you the types of functions he's using, the Python libraries, things like that. And so I think it's a very robust sort of an in-depth overview of how he works with clients. Kaggle, I'm sure you've heard of Kaggle. Love it or hate it, is one of the biggest communities for data science. And I recommend doing one of their competitions if you have the time. And then Tableau, this is an article for data visualization tips. Tableau, Salesforce, they have tons of articles and knowledge base pages where you can look through, and they have great information on how to format data and if you need any help as well. Make sure these are your best friend. Stack Overflow, things like that. And that's the end of my presentation. But please follow me on Twitter, Instagram. Those are my handles. I think these slides will be posted on LinkedIn as well. But if you have any questions, we can do a Q&A as well too. Thanks.
Thank you, Brandon. We do have a few questions. So the first one is from Lu Huang. She asked, how do you integrate all the data sources together?
Yeah, so if we have different data sources, so like an API call, so sometimes I've built custom interfaces, so like websites that do these connections. And so we have a blob storage site where we grab data from an XML output, and then we also have an area where we can store, like access files locally. Um, there's you can also build custom tools as well too.
The next question is, do you use Scrum at your work?
Yeah, so we use Scrum. We are more of an agile, I would say, but yes, it's about the same. We have a Jira board where we do issue tracking, things like that. And yes, but we don't have a Scrum master per se. It's more if we have project managers and things like that that sort of organize the flow of sprints and things like that. Yeah.
The next is by Chang Ho Yu. You have Hadoop on the slide. Is it overshadowed by MapReduce now? Can you tell us more about the trends of Hadoop and MapReduce?
Yeah, I would say Hadoop, I would say, is the most robust way of accessing data right now. We do a lot of Azure data mining, I guess, with Hadoop. So they have their own Hadoop service. I think it's HDHP or something, ADHP. I would say MapReduce is a little bit older, but if you're using Azure, then the Hadoop service is probably going to be the best one for you.
Next was from Martin Kunz. Do you see data analysts and data scientist roles overlapping more in the future?
That's a good question. I see an overlap already in larger companies like FANG companies and big tech or even big fintech. I feel like there needs to be that separation. Data scientists, they both help gather insights, but I think the data analyst is more of presenting the data so that the business can gather their own insight rather than getting kind of the answer from a data scientist. I hope they don't overlap because I feel like there's a very distinct difference. Good question.
Next is from Chris Grimm. Do you see a role for low-code tools in your stack?
Low-code tools, I'm not too sure what is meant by low-code tools.
Do you have
low-code tools, I see. So I guess low-code tools are like less coding, right? That makes sense. I believe so. So a lot of like Report Builder, Power BI, it's very low code, I would say. You do a lot of more querying, which is command. Essentially, it's still construct, but it is a structured query language. I would say with data analytics, it can be. I think it is gearing more towards low code, though. Yeah.
The last one is again from Lu Wang. Following Martin's question, your title is software engineer, but you also do data analyst and data science work, correct?
Yeah. So my title is software engineer. So I build applications in collecting the data, but most of I would say the majority of my work is building reports. We have a lot of reports that we use for voting. So like gathering the votes for Best Picture and other categories, and also we have the committees, the NOMS report and finals reports. So working with the CRM and building solutions is also what I do in addition to my role as a developer too.
We have 5 more minutes. Does anybody else have any other questions?
These are all good questions though.
Yeah, they are. Guess that's it.
Right.
Well, thank you, everyone. Hope you guys have a great time at DataCon LA. Hopefully this was
Thank you,
helpful.
Brandon, for your presentation and the attendees for the questions and interactions during this session. You can contact the speaker directly if there are any further questions regarding this topic, and please provide your feedback using the form that will be provided in the chat box. Thank you again, everyone, for joining today's presentation, and I hope you can gain some insights from this session. Have a wonderful day, and thank you for being a part of this year's DataCon LA.
I will be here if you guys, there's still 4 more minutes. Let us know if you guys still have any last minute questions. So
Yeah, I'll stick
feel
around
free
too.
to just stay.
I was
Just
wondering,
in
will
case.
this be access recording? Will I have access to this recording or no?
Correct.
Okay.
I don't know when we will have the recording. In the past, it was like a few days or sometimes a few weeks, depending of
Sure,
everybody's. Yeah, everybody got really, really busy. So yeah.
And then my slides, do I because I think I have new slides, but do I upload those anywhere as well?
I already posted the slides. There is your slide down here that I see, and but yeah, you can maybe provide your LinkedIn.
Oh,
You're
okay.
planning to put it in your LinkedIn, correct?
Mhm.
Yeah. All I saw was Instagram and Twitter. You can also put it there too, I guess.
Try that.
But yeah, I think that's. Yeah. I don't know if you saw the comments. They love your cooking analogies.
Do they?
So,
That's amazing. I didn't see them actually.
Hey guys,
Subhash is
Hey,
here.
Subash.
hey Brandon, thanks for sharing your presentation. Just a quick thing. So all the videos will be posted in the replay area for registered attendees, and for the general public will be available 2 to 4 weeks after the conference.
Got it. Okay, thank you for that.
And
Yes, I had that question earlier.
oh no worries. And if you have any new updated slides, send them to me. I'll post them in this area, and then I can have them uploaded in a slide share deck a few weeks after the event.
Okay, so can I just email them to you? The
Yeah,
new
just email it.
slides?
Yep, I'll
Okay,
take care
we'll
of it.
do.
Cool. Thanks,
Thank you.
Brandon. Thanks, guys. Oh, Hana, make sure to post the session feedback on the event.
I did that.
Awesome. Thank you, guys. Talk to you later. Bye.
The man himself makes an appearance.
Right? There is another question from
Oh,
Huan. She said,
okay.
could you please bring your slides to the last second page about the website?
Yes,
Blue
yes.
Huan, you can actually access the site, the slide here. I've put it in the chat.
Oh, great. That works too. And there will be updated ones too. I'm gonna send them to Subash right after I finish here.
So we have 1 more minute. Let us know if you have any last 1 minute question. Seems like there's no other questions and we are at the end. Thank you all. Thank you, Brandon.
All right.
And see
Thanks,
you
everyone.
at the other panels.
Will do.
Have fun, guys.
Thank you.
Bye-bye.
Bye.